In today's video, we're going to talk about how to multiply polynomials. So in order to do that, the first thing we need to talk about are the different types of polynomials. So we're going to learn how to classify polynomials. There's two ways to classify polynomials. The first one is by the number of terms, and the second is by the degree of the polynomial. So let's first talk about the number of terms. Okay, remember, terms of a polynomial are separated by addition or subtraction. If a polynomial is made up of one term, that's a monomial. So something like 3x squared would be a monomial. A polynomial made up of two terms is a binomial. Like a bicycle has two wheels, a binomial has two terms, and that might be something like 3x squared minus 4x. Three terms is a trinomial. Like a triangle has three sides, a trinomial has three terms. That could be something like 3x squared minus 4x plus 1. And four or more terms is a generic polynomial. We don't have special names for polynomials above three terms. And so that could be something like maybe 3x to the third minus 4x squared plus x minus 8 would be a polynomial, four or more terms. All right, second way to classify polynomials is based upon the degree. So the degree of a term is the total of the exponents of the variables. So for example, 4x squared is degree 2 because the exponent is 2. And negative 2x to the third y is degree 4. Notice this is x to the third and y to the first. So we take the sum of the two exponents. 3 plus 1 gives us degree 4. The degree of a polynomial is the highest term in the degree. So if we have a polynomial that's a degree 0, that's considered a constant. So an example of a constant might be the number 1. If the degree of the polynomial is 1, this is a linear polynomial. So that might be something like 3x. Okay. If the degree is 2, that's a quadratic. So that might be something like 3x squared. Okay. A degree 3 is, let me just double check this here, make sure I tell you the right thing here. And really quick, degree 3 polynomial is, the cubic. Makes sense. So that might be like 3x to the third, and you could even have plus a 2x squared, but it's the highest term degree. All right, next one down is a degree 4, and that is a quartic. And that could be something like 3x to the fourth plus 2x squared plus 5. And again, you look for the term with the highest degree, so that would be 4. All right, multiplying by a monomial. So if we have something multiplied by a monomial, we simply use the distributive property. All right, so here I would distribute the 5r to the 2r and the 5r to the 7. So 5r times 2r is going to give me 10r squared, and 5r plus 7 would give me 35r. You may have to use your exponent rules a little bit in order to do this. Right here, we're going to distribute the negative 3n to all three pieces inside these parentheses. So negative 3n times 5n squared gives me negative 15n to the third. Negative 3n times 8n, negative 3 times 8 is negative 24, n times n is n squared. And negative 3 times negative 8 gives me a positive 24, and then we still have the n. Again, to multiply by a monomial, that's that piece out here, simply use the distributive property. Turning the page in our notebook, we're going to now talk about multiplying polynomials, so there are no longer any monomials. Okay, the easiest way to do this, get this focused here for you, is to make a chart. Okay, so when we make our chart, we write the first binomial to the left of the chart and the second binomial on the top. So here we have x minus 6 times x minus 8. So we would write x minus 6 and x minus 8. So the second step is to multiply the terms together. So this is x minus 6 and x minus 8, and we're going to multiply. X times x gives us x squared. Negative 8 times x is negative 8x. Negative 6 times x is negative 6x. And negative 6 times negative 8 is 48. So this is kind of like a Punnett square in science. It's pretty similar. Okay, and then step 3 is to rewrite the results as an expression and combine like terms. So your results are found inside of the grid. So we would have x squared minus 8x minus 6x plus 48. We have like terms here and here. So we would combine those together. It gives us x squared minus 14x plus 48 as our final answer. A couple of additional examples here for us. Tilt this up just a little bit. All right, so first step, start with the box. First binomial down the side, so 9x plus 5 and 5x plus 10. 5x times 9x gives me 45x squared. 9x times 10 gives me 90x. 5x times 5 gives me 25x. And 10 times 5 gives me 50. So then I would rewrite this as an expression, 45x squared plus 90x plus 25x plus 50. Combine my like terms together, 90 and 25. So I have 45x squared plus 115x plus 50 as my final answer. All right, next example, same deal. We start with the box. First binomial down the side, negative 10x minus 6 and negative 9x plus 3. Negative 9 times negative 10 gives me 90, and x times x is x squared. Negative 10 times 3 is negative 30x. Negative 9 times negative 6 is 54x. And then 3 times negative 6 is negative 18. So rewrite that as an expression. I have 90x squared minus 30x plus 54x minus 18. Combine my like terms here. Gives me 90x plus 90x squared plus 24x minus 18 as my final answer. Okay, a couple more. Same idea here. Start with the box. And I have 8x minus 5 and 8x plus 5. 8x times 8x is 64x squared. 8 times 5 is 40x. 8x times negative 5 is negative 40x. And 5 times negative 5 is negative 25. So that gives us 64x squared plus 40x minus 40x minus 25. These two middle terms end up canceling out. A positive 40 and a negative 40 make 0. So my final answer here is 64x squared minus 25. Okay. Next example, I have 6x plus 3 squared. If we think about this in multiplication, when you see an exponent, it means you use your base with repeated multiplication 2 times. So in this case, my base is this entire expression right here. So in multiplication, This would be 6x plus 3 times 6x plus 3. And it's always a good idea to write that out. We're not just squaring the first term and then squaring the second term. Okay, that's a big mistake that algebra students usually make. Typically, they'll square the first term and they'll square the second term, and you do not get the same answer that way. So, good idea to always write this out using multiplication. And then your process is the same. So I have 6x plus 3 and 6x plus 3. 6x times 6x, 36x squared. 6x times 3 is 18x. 6x times 3 is 18x. And 3 times 3 is 9. Combined like terms, so we're going to have 36x squared plus 18x plus 18x plus 9. My like terms are here in the middle, the two 18x's. So I end up with 36x squared. 18 plus 18 is also 36, so plus 36x plus 9. And notice if I were to just square this first term, that would be 36x squared. Square my second term would be 9, so that would be 36x squared plus 9. And you end up missing that middle term here. So that's why it doesn't work to just square both terms. So please make sure one more time, write this out using multiplication. Right here we have a binomial times a trinomial. And this is pretty similar. You just have a slightly different box. So we're going to have a width of 2. And instead of having just 2 terms across the top, we're now going to have 3 terms across the top. So our box is actually going to become a rectangle at this point. So very, very similar. This is x minus 6. X minus 6. And then here we put x squared minus 9x plus 8. And we do the exact same process. So x squared times x gives us x to the third. X squared times negative 6 gives us negative 6x. Negative 9x times x is negative 9x squared. Negative 9x times negative 6. 9 times 6 is 54. So we have 54x. Oops, it should be negative 6x squared there. 8 times x gives us 8x. And negative 6 times 8 is negative 48. So notice your like terms always form along the diagonals here. So you can kind of go ahead and combine them without this step here if you like. So I have x to the third. Negative 9x squared and negative 6x squared gives me negative 15x squared. 8x and 54x give me 62x. And a negative 48. Last example, same idea. We're going to have a 2 by 3 rectangle. And here I have negative 7x plus 6, and across the top is negative 5x squared plus 7x minus 9. Right. Negative 5 times negative 7 is positive 35, x to the third. Negative 5x squared plus 6 is negative 30x squared. Negative 7x times positive 7x gives me negative 49x squared. Positive 7x, positive 6, 6 times 7 is 42, so I have positive 42x. Negative 9 times negative 7 gives me a positive 63x. And negative 9 times 6 gives me a negative 54. So I would finally write this out. So that gives me 35x cubed. Negative 49x squared and negative 30x squared gives me a negative 79x squared. Positive 63 and positive 42 is going to give me a positive 105x. And then I have a negative 54 at the end. This process would work the same way if you had a trinomial times a trinomial. And in that case, you would just have 3 by 3 grid here. You can extend this all the way out, depending on how many terms your polynomials have, but typically in the scope of Algebra 1, we see binomials and trinomials, and that's going to be about as big as it gets.